And now, as a next step, let's actually extract this whole configuration that is related to the web server also to its separate module. So basically, we have the instance itself, we have the key pair that is being created for the instance, we have the AMI query from the AWS, which is also relevant for the instance, and we have the security group, which also configures the firewalls for the instance. So basically, again, you see a pattern here. We have 4 resources or 3 resources and 1 data that are all needed in order to create an instance, right? So they basically all directly relate to that specific instance. So it makes sense to group them and make them into own module. So I'm going to copy all of this, and in the web server main.tf, I'm going to paste it in, and we're going to go through the same changes. So basically, we need to fix the references to all the values here, like the VPC ID that is not available in this main.tf, but rather has to be set from outside. So var VPC ID. We have a variable for my IP already here. We can leave all these fixed coded values if they don't change, or we can also parameterize them if we want to pass in different values. So for example, if we want to be able to decide which operating system image should be used for the instance, we can also extract this value actually here. So let's make it into a variable as well, image name, let's say, and we are going to need to pass that on from outside. We also have the server key, and the public key location is already parameterized. We have the instance type also as a variable. And for AMI, we are actually referencing the data, which is fine because we have the data in the same configuration. So that reference works fine. Now we don't have access to the module anymore because this module is actually defined outside. So we're going to parameterize that as well. So we are going to do var subnet ID. We also have the default security group ID, default SG ID. What else do we have? We have the availability zone as a variable. The key name is, again, a resource in the same module, so we can reference it like this, just like before. And finally, we have the entry script.sh, right? And this is basically a file that we are executing on the server. We can leave it outside and reference it using a relative path, or actually it makes sense to have it in the same folder. So I'm just going to move it to web server, and we can reference it like this as previously. So we have parameterized most of the stuff. Again, if you want to hard code some of the values because you know they're always gonna stay basically the same, then you can leave them hard coded. If you want to provide values for them dynamically, like different values like image name, etc., then you can set them as variables. And then we're gonna have to pass those variables when we declare the module. So we have parameterized all the values we need, and now it's time to declare all those variables in the variables.tf file. So let's go ahead and do that. So let's start from the top. We have variables.tf here, variable VPC ID. We can actually specify the types for all the variables as well as description, but I'm gonna leave those configuration empty for all variables, just for simplicity. So my IP. Then we have env prefix. We have the image name, public key location, so we have lots of values here to set. Which is actually very typical for modules because you're usually abstracting away a bunch of resources or packaging together a bunch of resources, and they have all these attributes. So modules usually end up having a huge list of parameters that you can pass in. So I think we have set or declared all the variables here. If we've missed something, we'll basically know it when we execute Terraform plan. So I think we have the whole list declared here. So now actually it's time to reference that module in the main.tf file. So just like we did with the subnet, we can reference it here. Say my app server. Again, we have the source, which is modules web server, and then we have all these variables that we need to set. So I'm actually going to copy all this just to save time, and obviously we don't need this variable. Okay, so I have removed the variable and curly braces, so we can actually go ahead and set those values. And let me actually check which of those variables I have already defined here so that I can reference them. So these are the variables defined in the root module. So it means that I can reference them here using var dot and the variable name, right? So let's assign the values one by one. First of all, the VPC ID we can reference from here. Let's actually copy this one. So we have the VPC ID. My app, we have the variable defined here. So I'm going to reference it. Then we have the env prefix, which I'm also going to reference. And this is also a good thing because if you have same variable used in many modules like environmental prefix or availability zone, you don't want to hard code them multiple times in module declaration. But if you reference it like this, you have to define its value just once in the Terraform vars file. And if it changes at some point, then you can just change it here and don't worry about fixing it in a bunch of different places. So that's why it's actually good to always reference values through variables and having them defined in this tf vars file. And let's continue. We have the image name. So let's define that here. So I'm gonna add this as a value. Public key location, we already have that. Instance type, we have that as well. And now here we have the subnet ID reference again. And the same way as we referenced it when we had to use it directly in the resource, we can do it exactly the same way. So basically using module dot the module name dot the name of the output, which is subnet. Let's actually close this one. Okay, I have too many things open. Right, so name of the output and the ID. The next one we have default security group ID, which let's actually go back to our web server. We don't actually need to reference it as a variable because we can reference it from the resource. So we have the default security group resource right here. So we can just reference it using the resource type and name and ID. So that means that I'm going to remove that from here as well, and we don't need to define it in the module. So one less variable, and then we have availability zone and the prefix. So both are actually variables with the same names. So I can just copy that. And there you go. We're referencing basically every value, either using a var or module or a resource name, which is a good practice because we're not hard coding any values. And now we have to make sure that all those values are actually defined in our tf-vars file. So we have it right here. Let's actually close it and let's go through them. We have my IP defined in here. We have the env prefix. We actually have it twice. Right. Okay, great. So we have the env prefix. We need to set value for image name. We don't have it yet. And this is going to be the previous value that we had defined. So now, for example, if we wanted to use another image, we can change this name or this regular expression in here. Then we have the public key location, which is already set here. Then we have instance type, also set. We have subnet ID, which we're referencing from a module, and we have the availability zone, which is also set. So that's great. We have all the values that we need. So now we are actually ready to execute this. So let's go back to our terminal. And now if I do terraform plan, there you go. We should see a warning from Terraform that module is not installed, because as I mentioned previously, whenever we create a new module or we make changes to already initialized or installed module, we have to run Terraform init again. So let's do Terraform init. And there you go. Now my app server module is getting initialized. Great. So now let's do Terraform plan, which will also tell us whether we have any errors in the configuration and also show us the changes it will make to our existing infrastructure. And there you go, we already see some errors. First of all, we have this error here because we forgot to remove a wrong reference from the outputs.tf. So this outputs.tf belongs to the root module, and it actually doesn't have access to any of those resources anymore because we have moved them into separate modules, right? We don't have those resources declared in here. However, if we still want to output that as a result of execution, what we could do is reference those values through the module component. So let's say we don't care about the image ID, but we want to output the public IP address of the EC2 instance. So what we're going to do is do module. Then we need the name of the module, which we called my app server. And that will basically give us access to the module. And inside the module, we need to access the EC2 instance. And as you learned previously, in order to access the resources and its attributes from a module, we have to output that object first in the outputs.tf of that module. So right here, we're going to do output. Let's call it instance, and value will basically be instance, AWS instance, the type. Then we have the server, and let's actually output the whole object. So this will give us the whole instance with all of its attributes, and then we can decide which one we want to access. So we are now exporting the instance using the instance output, and this is how we can actually access it in here. So this is the module, this is the output name, and now we need the public IP attribute. So again, gives us access to the whole EC2 instance because we have exported it or outputted it here. And then we can access any attribute on that object. And the second warning we got was about the entry script.sh. It looks like on line 60 where we're referencing the file, it cannot find that file in its location. So let's fix that. And the second error, which is referencing the entry script file, we can actually easily fix it by just moving that entry script outside that module. So basically having it in the root module will fix it. So now let's actually do Terraform plan again. And there you go. Terraform refreshed the state. It compared the current state with the desired state. And this is the output. So let's scroll up all the way. So first of all, the VPC and subnets are already created, so they will not be created again. However, here we have security group, an existing one that will be destroyed, and my app service, as well as SSH key, and new resources will be created in their place. So security group will be recreated, as well as the server itself and the key pair. And we also have change in the output, which is basically that AMI ID will be removed as an output. However, we're going to see a new public IP of EC2. So now let's actually apply this. And as you see from the error message itself, we have a duplicate key pair, which seems like a timing issue because the SSH key was destroyed or removed like other components, and probably the new one was created too soon. So if we re-execute or reapply this, it should actually work. And whenever we actually get an error in Terraform, something called a crash.log file gets created. And this basically gets auto-generated by Terraform, and it gets created inside the root module. So if you click inside, you see basically logs of failures of Terraform apply. So you can see a full log here. So crash.log is actually one of the files that we also want to ignore and not check in. So in the .git ignore, we're just gonna add this crash log file. So just as a side note, so ignore crash logs, and let's do this. And as you see, it's grayed out as an ignored file. So let's head back to our console. Let's actually check our AWS. We have one server which is terminating, otherwise everything is clean. So I'm gonna try to execute this again and see what happens this time. And there you go, we have two resources that were created. And now if we go back to our management console, there you go, we have one instance which is running, as well as the key pair got created. And we have the public IP address printed out here as previously, since we're accessing it through the module. And now let's actually try to SSH into it. So we are inside of the server, and we can actually now validate that the entry script, shell script, also ran successfully. And since our entry script basically installs Docker, we can just validate that there is Docker already installed on the server. So I'm just gonna do Docker version, and there you go, we have Docker command available. So the script ran successfully as well.